Let us start the installation of our miniRaman microscope. First, we should find a nice working area for it. As you can see, footprint is extremely small, so there should not be a big problem to find a place. From the technical point of view, it doesn't require any special conditions. It could be just normal working table, and it can work with laptop or normal computer, as in our case. First thing what we should do, after unpacking the device, we should connect power, as I do now, and USB cable. So we hear the sound that connection has been started. Probably you can see here the blue LED. It means that it's connected to the power. There is also another indicator here, which is yellow right now. This is a microcontroller which is loading for the miniRaman spectrometer inbuilt in the microscope. And we should wait until it's blinking blue. Could take around 15 to 30 seconds. You don't see it probably from the angle of the camera, but I see it's already blinking blue, which means that it's ready to connect. And first, during the first installation to the particular computer, you may have a problem with connection of the all electronic accessories. They may require proper drivers. And when you will go on our website and you will download the folder with our software, we have inserted the drivers. And if you have any unrecognized accessories, just suggest the driver from our folder. This would be the first step. The next step, simply run miraspec software, and then it will appear with this user interface. The next step, we should connect by pressing connect button. We connect the microscope, and you can see here there is an indication, the model of the miniRaman spectrometer number 24, produced in 2021, and then temperature inside the microscope is 28 degrees, humidity is 31 degrees, and this yellow status bar means that XYZ mapping stage require calibration. In order to calibrate the mapping stage, we press the home button here, and you hear the noise, which means that stage is under calibration. It's done now. Now mapping stage is ready for operation. Let's check the other functions of the microscope. Let's say laser. I press the on button, and probably you can see here the red spectrum. That is a spectrum of the inbuilt polystyrene sample, which is always present and doing calibration during every Raman spectrum is quiet. This is inbuilt sample in the microscope. There is also another channel. I can zoom this area. The blue one, which is supposed to be the Raman spectrum of the sample. We see a noisy background because there is no sample. Let us try to find a sample. Before doing that, we should connect the visible camera. I just need to start it from the software, and you see some noisy image appeared here. Let's try to place some sample. This is a CERS substrate, so I just place it into a sample compartment. We also have a clamp for fixation. The next step, we could try to add light for transmittance microscopy or for reflectant light microscopy. Let us try to find the proper focusing. It's moving laterally, And I actually shouldn't wait, I can also move it in axial direction and lateral direction as well. Okay, a bit more. Hopefully we will see an image here soon. Okay. Getting closer. Nice. 0.02. Good. We arrived. This is the edge of the SERS chip. Let us try to explore the surface, another edge. Yeah. I don't know. We could try to get some Raman spectra probably from this area. Sorry, SERS spectra. Okay. Now let's turn on the laser. Fit to window. And what you can see, I hope you see that, we simultaneously collect two spectra. Red spectrum is the spectrum of the polystyrene sample, and the blue spectrum, it's a spectrum of BPE analyzed on a SERS substrate. I hope you also could see the laser spot here simultaneously. Let us try to minimize the amount of visible light so you can see the laser spot better. And actually you can measure the size of the laser spot. If I will increase the amount of laser light, like that, yeah, you could see the actual spot size. This is the scale bar in microns. So the spot size here by the visible image could be estimated as around 5 microns with the current microscope objective. Of course, you can change objective to a high magnification one, and the best spot size you could reach with the 785 nanometer excitation laser would be around 0.8 microns. Okay, let us check some other features. First, what you can see, and I really enjoy that we can simultaneously see the laser spot, so we can see any processes happening on a sample, let's say overheating or sample damage, together with the Raman spectrum. And as you can see, there is no interaction of the ambient light. Yeah, oh, we have saturation. Sorry, I can do a few things. I can minimize the laser power or reduce the exposure time. So right now, this quality of the spectra we get only at 100 milliseconds of the exposure time. And as you can see, if even I will turn on the LED light, so we can see on the only laser here, there is nothing extra disappeared in a SERS background, which means that visible microscopy does not provide any interaction to the Raman spectrum acquired. In terms of visible microscopy, we have two options. This is a normal reflected light microscopy. However, we also have off-axis light microscopy. Let me turn off this one and turn on off-axis illumination. And you can see you immediately, let's expand this screen, you immediately start seeing features from the light coming from the side. You can see the structure of the sample much better. Nevertheless, you can even combine, let's say, off-axis and on-axis reflected light microscopy. We can try to optimize the ratio so you can see both side illumination, yes, and high resolution imaging with normal light propagation, together with the laser spot on it, of course. Okay, let us try to get image like this. The next step for us would be naturally Raman mapping. In order to do that, let's say we like this point as a starting point for the mapping, and I press this button and it transfers the actual XY position of the stage into the mapping settings. Let it be 100 per 100 micron step size and probably 20 per 20 pixels map, yeah, in order to make it fast. And I actually press start. Here it was asking me where exactly should I save the file. And what we can see, live search spectrum, also, yeah, we can see the laser spot, where exactly we do mapping. And how about the actual source map acquired? It's here. You see, pixel by pixel it appears. So software is flexible. Let's say you can expand the map, or you can see only the mapping process. Here, in each pixel, you just click and you will see the spectrum, like that. Mapping process is fast. For the beginning, I hope this is probably enough. One important feature which I want to demonstrate you, basically our mapping is robust, and I can hold microscope like that and you can see it's still map. Even I could invert it. Well, you can see some defocusing. That could happen. But nevertheless, it is just 7 kilo in weight. So you can have much more flexibility than before with Raman microscope like this. Let's see the status of the Raman map. I guess we should visualize it on the source peak. It would be better. Yeah, here it is. So of course, due to the step size, we cannot here estimate the actual lateral resolution. However, on the next videos, we will show you that we actually could demonstrate and prove diffraction limited performance below 1 micron. So basically, this miniRaman microscope has performance comparable with research-grade confocal Raman microscopes. Mapping is finished right now. The only difference is that it is much smaller. It allows us to see many things simultaneously. Laser spot, visible image, Raman spectrum, and we can do calibration of laser intensity and Raman shift during each Raman spectrum acquired. Thank you for your attention. I hope that you also will like the performance of our great device. Thank you.